Okay, so let's read this. It says the value V pounds of a certain new car at time t months depreciates at a rate proportional to its value. Okay, so the word depreciate obviously means to decrease, to go down. We'd expect that, wouldn't we, of a car? Okay, once you own the car, over time then its value will drop. Okay, so in A it says write down a differential equation which describes this depreciation. So just to sort of emphasize this here, I put an equal sign above there, yeah, because in an equation we need to have an equal sign. Okay, and of course with the differential equation we need to have a differential in there, yeah, as we've seen before. So it needs to be d something by d something. So let's see if we can establish this from this top line here. So the value V of a certain car at time t months depreciates. Now it says here at a rate. This bit's important here, at a rate, because the rate just looks at how it changes. So in terms of what changes, we need to consider, of course, the V, okay, the value V. So V changes, doesn't it, with respect to time. So we could say dv dt, that would be our differential, okay, because the value of the car changes with respect to time, okay. So dv by dt is looking at how it changes. And notice, because it depreciates, okay, the value goes down, yeah? So if V was a curve, okay, for the value of the car, it would slope downwards, wouldn't it? Because over time, the value of V would drop. So we'd have a negative gradient. So dV by dt should be negative, okay? Also, it says it's proportional to its value. Now, it's not going to be equal. When we say proportional, we use this alpha symbol, if you remember, yeah? That just says to us that it sort of grows in a similar sort of relationship. So in this case here, we have to use that symbol, okay? Just like we used at GCSE when we saw proportional. So to its value. So in other words, the rate at which it changes is proportional to its value, okay? So we can put V here, because it's proportional to its value, and we know its value is V. We have to put a negative there to show that it's decreasing, yeah, that it's got a negative gradient. So then to answer the part A, write down the differential equation. Well, we're not quite there, because this sort of looks at the proportional relationship, okay, and we need an equation. So if you remember then from GCSE, we could change this into an equals if we brought in a constant k, to say then that dv dt is some negative constant k times the value v. Okay, so there's our differential equation. In B then, it asks us to solve the differential equation. So just as we did before, we have to separate the variables. Okay, so that means we need to get the v onto the left hand side with the dv. So it's just 1, won't it? It'll just be 1 over v dv. So we can integrate that. On the right hand side, we'll keep that minus k there, because it's just a constant, and take the dt up. Okay, we can integrate that as well. Okay, fantastic. So we separated the variables. Now, 1 over v, of course, becomes ln v, yeah, because it's linear on the bottom. That's the standard integral. Minus k is a constant, so when you integrate it with respect to t, it'll just become minus kt. Okay, differentiated back, you will get back to minus k. Don't forget though, because you've integrated with no limits, you have to put a constant of integration. Okay, so we've got a constant here in regards to the proportionality issue we had at the start, and then we've also got a constant c here, different constant in relation to the integration. Okay, but they also tell us then that the car initially costs 14,500. Now initially, of course, means when time is 0 at the start. Okay, initially v will be 14,500, so plug it in, ln 14,500 minus k times t, which is 0, plus c. That will go, which means c is equal to ln 14,500. So what I do then is, because I've got my constant, I just sub it back in there, and I get ln v is minus kt plus ln 14,500. Okay, so I've worked out my constant c. Brilliant. But I also now need to work out my constant k, right? And I'm able to. I can work out my constant k because they've told me something else. it says it's expected to be worth £10,000 after 2 years. So we've got another sort of boundary condition now. When t is equal to, well, 2 years, the value will be 10,000. Now you've got to watch out on this because I've been caught out on this question before. I'm not going to write 2 there, okay, because even though it's 2 years, time is measured in months. So make sure you read the question. T, of course, then will be 24, yeah, because 24 months is 2 years. So look out for that. So ln 10,000 will equal to, so I'm putting it in here now, minus k times 24 plus ln 14,500. Okay, what I can do then is, right, I can get these logarithms together, okay, and in fact I can put this over this side, okay, so I've got minus k times 24, which is minus 24k, take it over, so that'll be 24k, equals to ln 14,500, and take that ln 10,000 over, and I have that, okay. I then going to rewrite this as a single logarithm, okay. When you're taking away logarithms, you can write it as a division and a single logarithm, okay. So you have that. Simply then, to get k, all I've got to do is take that 24 over, okay. So 14,500 divide by 10,000, and then of course the whole thing divide by 24. And when I did that on my calculator, I got 0.01548. Okay, so 5 decimal places there for a question like this would be appropriate. Okay, so then what I'm going to do, I'm going to go back to this here. Okay, I'm going to go back to this here, and I'm going to sub in my value of k. So I can say therefore ln v is equal to minus 0.01548t plus ln 14,500. And all I've got to do then, because it is saying, doesn't it, in the question, it says solve the differential equation, I need to get v equals. So what I'm going to do is I'm going to take that over. So I'll have ln v, take away ln 14,500 equals minus 0.01548t. I can write this as a single logarithm because we are taking away. So we divide that, and then of course 2 more steps. Because this is ln, I can take that over the other side, and of course it becomes e. Okay, when I take it over, so you do the inverse of ln, which is e. And then finally then, this 14,500, take it over and multiply. And there is my solved differential equation. And I can work out the value of v at any then particular time.